Okay, cool. Welcome to lecture number 7 with our decal. Today, we're going to be talking about special applications in cloud computing. So the first half, we're going to be kind of talking about some ones that are more useful than others. And then the last quarter or last half, we're going to be talking about like really fun ones that you didn't really know that AWS actually offers. But we'll be doing an investigation into all of those. So let's get started. Some quick announcements. Lab 1 was released last Thursday. It's really not too bad of a lab. It's just you need to write at least like 10 to 12 sentences about, there's a prompt, but you basically pick a AWS service that you found really interesting, kind of do an investigation on it, figure out what companies are using it, what it's used for, and give an example of how you would use it on your own. And it's a fun way to actually explore like one that you're really interested in case you're interested in implementing it into a project or just need some fundamental knowledge of it. My screen is really blurry. 1 second. There we go. Now you guys are out of the cloud. Okay. And then, yeah, so the lab 1 will be due next Thursday. It's out of 20 points, but mostly we're looking for participation, completion. And if you do that and turn it in on time, well, you'll probably get a full score, but good to know. And then we're going to be diving into the special applications for today. So as always, if you guys have any questions throughout, please shoot it into the Zoom chat or raise your hand and I'll answer and clarify for everyone. Alrighty, so in AWS, we know that there's a lot of compute services, analytics services, and security services, but we haven't really talked about some of the more nuanced slash bizarre slash not as well known services that you might be able to use. And AWS has a pretty big portfolio where they're encompassing so many different computing services. So our investigation is to kind of get to know a little bit more about those and to see which ones we might be finding useful in the future. So in the first, I guess, subsection of special applications, there's some content delivery applications that are really important and are actually quite commonly used. So to begin, I want to explain what a CDN is, or a content delivery network. So basically, content delivery networks are systems that deliver data across the globe, and they have special characteristics that make them very feasible and very efficient. Number one is content delivery networks have really, really low latency when users are trying to access data. And number two, they are very reliable and secure. So when you're transporting data across the globe or across certain regions, you know that your data is protected. So to give an example, what is like a CDN really? Like what service is that and why would it be used? So why do we need CDNs? Well, think about YouTube or any like video streaming platform, or for example, Twitch, right? And then you're trying to, let's say you live across the world and you're trying to access videos that are stored in Twitch's or YouTube's database that's located like in America, right? And you live in China. It takes so long for you to actually submit a request and get a video back when you're trying to view it, if you're traveling all across the world with that request and coming back with a request. So with a response. So this is why content delivery networks are so effective. They use something called caching to make sure that the content that is most frequently accessed are placed in areas that are more accessible by all users. So let me give you an example of what I mean by that. So let's say we are here in Berkeley, right? Our hometown. We are looking to stream the latest Cal football team or record a video of the Cal football team, and we want to stream it across the world. Everybody wants to view this great football team. We'll use like this Saturday's game against Oregon, for example. We're going to stream the Oregon game. It's going to be awesome. We want everybody to watch it. And let's say that there's a lot of people who are interested in watching this video and they live everywhere. Let's say someone lives in Bikini Bottom, right? They live under the sea, but they want to watch our video. Well, that kind of poses an issue. Although they live relative to the earth, like pretty close, the request to view the video gets a response time of like 14 seconds. So when you, as SpongeBob or Patrick, want to use the football team or view the football team playing, you're taking 14 seconds to access the video and watch it. That's a really long time, and that's very high latency. And then let's also say that Thanos wants to watch the football game. This dude lives like however many light years away, like using Marvel lore. He's like beyond our planet, beyond our galaxy. Let's say when he wants to watch the Cal football team's video, it takes him 2 light years for him to get a response when he requests to access and watch the video. That's insane. Like, imagine you're waiting 2 light years to watch a football game. Like, that's the football games, like everybody on that team's already like dead by the time you're watching the video. That's a problem. That's high latency. We don't like that. And then let's say some dude on the moon, an astronaut, wants to watch the game as well, and it takes him 4 hours to watch the video. That's not good, right? So there's a solution to that. That's why CDNs exist. Basically, you place these cache servers near areas where a lot of people want to access your content. And that way, instead of routing your request all the way to Berkeley to try to watch the football game, they're just going to the nearby cache zones to watch the football game. So in this case, 14 seconds turns into like 2 seconds, 2 light years turns into like 2 seconds, and the moon turns into 2 seconds. Like, you're going to be able to have fast response times. And that's why it is so crucial, because pretty much all content delivery services across the globe have some sort of CDN. So hopefully that example kind of conceptualizes the idea and the powerfulness of a CDN, or a central delivery network. So not everybody can watch the game. And hopefully we win this Saturday. Alrighty, so CloudFront, to follow up off of that, CloudFront is basically just AWS's version of a CDN, or a central delivery network, or content delivery network. It's their service that they use to solve these problems for high latency and security. So basically, you can send your content globally, or it could be like region restricted. So if you only want to stream or like have your content be accessed in like America or China, you can do that. CloudFront allows for really high delivery of static or dynamic content. So static is like, for example, a video on a web page, and then dynamic is more like something that changes very frequently, maybe like not necessarily a live stream, but some kind of content that isn't so static, that updates frequently. Like if you make an update to like something, like a video or something, it'll reflect as dynamic content. That's an example. And there's 3 levels of access in CloudFront's cache zones. Let me see the question. Would streaming sites like Twitch use CloudFront? That's a good example. Yes, great question. So I didn't want to say Twitch per se, because streaming is like a different type of content delivery, because it's like real time. So they don't necessarily need cache zones, because they're live. So when you're sending a request, you want to get it back in real time. Services like Twitch might not use CloudFront for streaming, but when they like, Twitch has like YouTube video, or Twitch has videos that are like posted by the user. And then when another person across the world wants to watch like an already recorded live stream or something like that, CloudFront is a good use case for that. So you can think of YouTube as a better example. When someone posts a really popular video and everybody in the world is trying to watch it, that popular video, instead of only being held at the source location, it'll be held in caches in the AWS edge locations. So yeah, that is why we want to get into the 3 levels of access. So the origin is basically where your content is solely, like the real content or the data is stored. That's where all the content that you want to distribute is stored. So in my example, if I was headquartered in Berkeley and wanted to stream the football game, Berkeley is the origin. And then we have another level of access called regional edge caches. So caches, remember, they're a temporary storage for data that is frequently used. So regional edge caches allow us to have that fast access time or the low latency, because now we're accessing data within a cache, and we know that caches store data that is frequently used. So in this case of the football example, I can have my caches be located in like China, America, Europe, and then people within those regions would access the video through the caches. And then edge locations, they're basically like a subset of the caches. So they're like very distinct and pinpoint areas where you can get caches. And so in that case, we can have a cache location in Berlin, cache location in Beijing versus rather than the whole country. And I think I need to go back and clarify on my example with the cloud football team or the Cal football team. I think the live streaming is not a good example. I meant, let's say we wanted to record the football game and then post it. That would be a better example because it's not real-time access. It's content that you're storing in Berkeley and then sending to the cache locations. So yeah, sorry about that. Let's clarify. But if you look at this photo right here, you can kind of see like a visual idea of what exactly the whole process is. So let's say you have Thanos, SpongeBob, and some astronaut on the moon, and they're trying to watch the recording of the Cal football game. They would first check to see if the football game is stored in the edge locations or the nearby caches. If not, they'll check the regional edge locations. And then if not, they have to actually go to the origin server to get the content. And that's why caches have this behavior where if you're accessing something that's not frequently accessed, you as the first person who accesses it in a long time gets a really slow response time, but other people afterwards will get a shorter response time because now that content has been stored in like nearby cache locations. So yeah, that is a CloudFront. Does anybody have any quick questions about that? Sounds good. Yeah, and caches are like, they're a type of machine level concept. So you'll probably learn about it in CS61C or like some more hardware related CS courses, but basically caches, just to remember, store temporary data that is accessed frequently. And a lot of caches are located in your computer's RAM or in hardware. So when you're accessing stuff, it's very quick and you get fast response times. So yeah, that is CloudFront. Cool. And moving on, we now kind of go back to a previous mentioned lecture. We talked about like this service called AWS Global Accelerator, right? I think maybe if you remember from that last lecture, you can kind of see that there's like similarities. Like we're still revisiting the idea of low latency. So like, how is this any different from AWS Global Accelerator? If you remember this photo, it's like when you're sending a response or when you're sending a request to a web application or something, it'll route your request to the nearest IP address, and then that IP address will kind of process the request for you. So it's like, how is that any different from AWS CloudFront? Like, what is the really, like, I'm kind of confused. Well, this is to kind of clarify. To review, Global Accelerator is just a way to send traffic through the AWS global network. Traffic gets distributed to like the area or the IP address that has the least amount of traffic, and that improves your deliverability, decreasing latency, and it reroutes to certain regional endpoints where you select. So yeah, it's like kind of like the same idea, right? Like what's the difference? Why do we need CloudFront versus Global Accelerator? So both services improve latency, or they decrease latency. So thus improving performance. And they both utilize AWS's edge locations. But the key distinguishment between these two services is that CloudFront is based around caching, and then Global Accelerator uses IP addresses. So in a way, they're mutually exclusive, because CloudFront is for content access when you're trying to access something and you don't want to access it from the main database or the main server, you want to access it from the nearest location possible. That is what CloudFront is best for. Whereas Global Accelerator is suitable for like sending information and sending real-time data or sending some kind of request. Because Global Accelerator, right, you don't really need caches to help in this use case when you're sending information, because you're not retrieving something back. So that is a good distinguishment. CloudFront is basically a pull effect, grabbing something, and Global Accelerator is like putting something, increasing the amount of time to put or pull in totality. And gaming is one example when Global Accelerator is really effective. When you're playing games and you're connected to like a multiplayer lobby or like a multiplayer server, when you're playing the game, you are sending a lot of information from your clients. So when you're at home on the PC playing games, you're sending a lot of information over the internet to wherever the multiplayer server is located. Global Accelerator would be suitable for that, because you're not necessarily pulling information out of the central database like CloudFront. So yeah, that's a good distinguishment, and we'll probably quiz on it. It's nothing too big to remember. Just remember that these are kind of the big differences, and I myself was struggling to understand this as well. So yeah, any questions so far? Cool. Nice. So we just talked about CDNs, content delivery networks, how they are used, and the AWS service to accommodate that issue/approach. So now we want to kind of step back a little bit, kind of move on from what we just learned about CDNs and talk about storage. We're going to be revisiting a few services, but by doing so, you're going to be really able to digest kind of what services to use for storage when you're dealing with EC2s. So we want to visit storage services in EC2 because that's one of the primary use cases for storage services in AWS. So you'll see some of these we've already talked about before, but now we're going to revisit them and see why we need to use these services. So EC2 has several different storage options that are supported. They have EC2 Instance Store. We have EBS, Elastic Block Storage, EFS, Elastic File Storage, AWS Backup, which you've seen in the last lecture, I believe in the last lecture, not in the analytics category, but in like the snowball family category, like the resource delivery category. But anyways, and then we have Storage Gateway, which we also talked about too. So it will be helpful to digest this because these are the primary ones you should be taking away throughout this entire course when you're talking about EC2. These are the ones you really want to use. Cool. So AWS EC2 Instance Store. So this is kind of a little bit confusing, but I'll try to explain it as best as I can. So every virtual machine in the cloud is a virtual machine, right? It's like a simulated computer. Every single one of those virtual machines have some kind of storage associated with it in AWS. So what EC2 Instance Store is, it's basically the storage that is attached to your virtual machine when you initialize it in the cloud or in AWS. It's the local storage that's physically attached to the host computer / virtual machine, and it can't be removed. So EC2 Instance Store is the service that allows you to utilize that storage. There's actually some key distinguishments about this type of storage specifically. One of the biggest characteristics and biggest benefits of using the attached local storage is it has very fast I/O speeds, right? Because when you have storage that's attached to the virtual machine, that's as close as it can get to the actual system itself. So when you're requesting things from the local storage, it's going to be very quick rather than you're sending requests to get it from like a database, for example, or like another storage service. When it's attached to the virtual machine itself, it's going to be very fast. You're going to get fast response times when you're doing some kind of computation and you need the storage. The only downside is that the storage is actually temporary. So when you run up and spin up an EC2 instance or your virtual machine, every time your virtual machine stops or your EC2 stops, the temporary storage or the EC2 instance store associated with that virtual machine, all the data in it gets lost. So it's kind of like a double-edged sword. When you're dealing with things that only need temporary storage, this would be a perfect use case. But when you're trying to have data that persists with the EC2 instance store is not the best case for this. So to put it into kind of perspective, an example is like when you create an application and you use EC2 to process like photo compression on websites. So like if I built a web app that like allows people to upload photos and then in return they get like a compressed version of that photo, that would be a great opportunity to use EC2 instance store, because when you take in the photo, you don't really want to keep it forever. You're just keeping it with your virtual machine in order to run some kind of process on it and then give it back to the user. We don't want to actually store that user or care about or store that picture, or we don't need to really keep it forever. So that is a perfect use case for EC2 instance store. Things that are temporary where we don't want to hold on to them forever, we want to either get rid of it as soon as the EC2 instance is over. That is a perfect use case. So we initialize an EC2 instance, have it do some kind of computation to compress photos. Once the computation is done and the compressed photo is sent back to the user, we don't care about the photo anymore. That's why temporary storage is really good for this. So yeah, that's EC2 instance store. It's the storage attached to the virtual machine in the AWS cloud. Cool. And then the contrary, EC2 or Elastic Block Store is kind of like the opposite of it. So this is for the cases in which you want your data to persist. So Elastic Block Store is a service that allows you to store data in the form of volumes. It's called, that's what the term is for like the container of storage. You can store data in volumes, and then those volumes can be attached to EC2 instances in which they are able to like persist when your EC2 instance goes down or you spin up a new one. So this is the standard storage for EC2, and it's what you'll probably have to use if you're running or you're creating an EC2 application and you need some kind of storage, because most use cases, we want storage that persists data. So some examples of why we would use EBS or Elastic Block Storage, we want data that persists beyond instance cycles. So before or after an EC2 goes up or go down, we still want that data. So that's one use case. We want quickly accessible data, although it's the access to the data is not as fast as the local storage in instance store, it's still very quickly than if you had like the data stored elsewhere. So we have really fast data access. You can actually also run a database on the Elastic Block Store. So you can actually create a database within the volume. And that is also a use case for when you want to attach it to an EC2 instance. Rather than using AWS's database services, you can actually just create a database within every volume of the Elastic Block Store and then use that as a database itself. So that's like a flexibility factor. And then, yeah, long-term storage is the must in this case. So a really easy example to kind of visualize it, contrary to the photo compression website, let's say you make a personal photography website, and you upload photos to the website and you use EC2 to handle some kind of functionality. Now that you've uploaded the photo to the website, now we want to keep those photos. So when you access the website again, or your website goes down and another EC2 instance makes the website go back up again, the pictures are still going to be persisted and you'll still be able to access them. So that is a case in which we would use elastic block storage. So to kind of compare EC2 instance, temporary, fast, elastic block storage, not as fast, but persists. And it's kind of like a Legos, basically. If you were to like have two bricks representing EC2 instances and then a bigger brick representing the elastic block storage, when you detach the two bricks that serve as the EC2 instances, you can take other bricks and attach it to the longer brick, or the elastic block storage brick. Let me kind of draw that out for you here. So hopefully you can see right here, but basically you have your EC2 instances right here, and then your elastic block storage. Oh my God, your elastic block storage. And then these are your EC2 instances. Your elastic block storage will stay here, even if you detach this one, or add new EC2 instances, or remove them all. Your data will still always be on this block. So that is kind of a visual to, oh my God, that is terrible, terrible quality. But yeah, EBS, persistent storage, you can detach EC2 instances from it and still get the same result. Are there any questions about those two services or any clarifications? Okay, moving on. We can always ask those later. Cool, and then next one is elastic file system. This one's still not as used as much as elastic block storage, but still has some certain use cases in which it's super nice. It's basically a serverless network file system. It supports a lot of operating systems, but not Windows. It like supports Linux for some reason, but not Windows. And this is like a more expensive storage for data. It's more expensive than EBS. So what elastic file system does, it's kind of like the same idea. Data is stored and it's persisted, but now it's in the form of files and directories. So you would use EFS if you had a main directory for like critical applications, and you would use EFS for lift and shift of existing applications. So what I mean by that is like if you have back end or like code or static code that's like written in files, and like you want to take them and apply them to a lot of different EC2 instances, for example, you can do that. So I don't know if that's clear, but let me give you an example. Like, let's say you build a static HTML website and you want the website to be hosted across a lot of different EC2 instances. All the EC2 instances can access the same HTML file if you were to use elastic file system. So like, let's say I had an HTML file that was just like a home page. I can upload that home page into the elastic file system, attach however many EC2 instances I want to it, and then they would all be able to access that same front-facing file. So in the case that one EC2 goes down, the other one has the same file to refer to. And yeah, same idea as EBS, but based around files. So things like data, there's like different use cases for this service rather than EBS. But same idea. So that is elastic file system. Alrighty, and the next two we have our review services of the ones we covered in previous lectures. So AWS backup, it's just the data backup of your AWS service instances. So you can like integrate it with EC2, EBS, EFS, etc. You know, it's your typical backup system like iCloud. Like let's say you have an EC2 instance or EBS instance and you want to take a snapshot of it. This would be a good use case, AWS backup. If you need frequent backups of certain environments, like development environments or testing environments, backup is a good use case for that. And if you want different versions of like something you're building, this would also be a good use case for that. So let's say you're in a team and then you're creating an EC2 environment and then you're trying to test different versions, like you have like a deployment version, a live version, and then like a test version. You can use backup to kind of version control and to save different versions in case the new one you created fails or the testing one fails. You can refer to like the older versions prior to that. So in a lot of software development processes, there's the testing environment, there's the development environment, and there's like the live environment where all the people can see if they were a customer. This is a way to kind of keep track of different ones and restore different versions. So it's like a version control in the cloud, but you can apply it to different services. So yeah, let's say Instagram was trying to create a new feature for Instagram's app. They could use backup to kind of keep track of the current one they have. So when they develop a new version and it fails, they can revert back to the old one. So that's AWS backup. And it's a same category as storage because you can store whole instances or whole snapshots of things. And then last but not least, we have AWS Storage Gateway. Remember, this is kind of like the sending of resources from on-premises to cloud. It's basically a hybrid storage service. So when you want to keep some of your use, or when you want some cloud use, but you still want to maintain a lot of your hardware on premises, Storage Gateway is a way for you to connect your on premises to the cloud. So in this case, like let's say you have backups that you created on premises, you can move those backups to the cloud and they'd be stored in like S3 containers or whatever. It also reduced costs for hybrid storage. So you don't need to necessarily have a cloud data storage system. You can just have Storage Gateway attached to like S3 and then only get charged for when you send data over to the cloud or snapshots or backups over to the cloud. So it reduces costs in the end. So you don't have to necessarily host something in the cloud. And then it also has low latency data access. So if you try to get something from the cloud as well, there's low latency. So it's very fast response times. This case is used for when you're wanting to have some kind of off-premises functionality in your application. So for example, analytics, you can use Storage Gateway as the medium or like the transportation of your data to the cloud for analytic purposes. So I have like a data about ads that I have on premises. I can send that data about those ads using Storage Gateway to the cloud and have an AWS service perform some kind of analysis on that data and then use Storage Gateway to get that data back now onto the premises. So that is Storage Gateway. It's kind of like the train that connects one point of the cloud to your on-premises. Not necessarily a storage service. It's like a storage transport service, data transport storage. So yeah, that is Storage Gateway. So yeah, to recap, Instance Store, very temporary. Elastic Block Store, persistent. Elastic File System, persistent, but subset of Elastic Block Storage because it's files only. Backup, ways to create snapshots, different environments, and Storage Gateway, the train or the bus or the transport that sends your data over. Train in a figuratively speaking. Cool. We'll take a 5-minute break and we'll get back into it. We have a cool demo coming up, so I'm super excited to show that to you, and then we'll be done shortly after. So let me set a timer for 5 minutes. If you guys have any questions or have any general things you want to talk about, feel free to leave it in the Zoom chat, but we'll be back. Okay, and excuse me. And then if you guys are taking a break, you can ignore me or zone me out. I just kind of wanted to talk about random stuff. I checked the stock market today, and Meta is down 25% based on their earnings revenue. Pretty crazy stuff, man. The metaverse is hitting a slow bump in the road, but Mark Zuckerberg's gonna pull through. What else? In Britain, they basically took out the prime minister, Liz Truss. She was like a really conservative prime minister that just got instated, and then they just removed her after she did some crazy things and did stuff to the economy. So now they're trying to figure out another prime minister in the process. So that's Britain news. What else is going on? Twitter got bought and the CEO was fired. I actually did not keep up with this. Yeah, Twitter got bought by Elon and the CEO was fired. Yes. So that I think is going to happen informally. The transfer of power is formally happening on Friday. So exciting stuff. I think he said he's going to cut the workforce into like 25% of what it is, which is crazy. A lot of software engineers are going to lose their jobs because now we're going to be having some kind of bot system, a lot of automation going on. Elon's really good with automation because look at Tesla, man. But not the same thing. What else is going on? Sports things for the cricket championship. India beat Pakistan last week. Go India. Oh, one thing. So I don't know if you guys keep up with baseball, but the World Series is happening soon. And it's the Phillies versus the Astros. Here's a funny thing. Every time the Phillies have won a World Series, there has been an economic recession a few months after. And it's happened 3 times already. So the last 3 times that the Phillies have won the World Series, there's been a recession that comes shortly after. And right now, the Phillies are in the World Series, and we're getting signs of recessions coming. We're already kind of in a recession. So it's kind of like a gambler's fallacy, hocus pocus. But if the Phillies do win the World Series, let's stay on our feet and hopefully realize that this is just a huge coincidence, because big economic downfall right now in our lives, especially when we're in college, we're going to be hit pretty hard, but we'll come back. But just something to mention. What else is going on? Yeah, if I think of something, I'll say something. Oh yeah. I also wanted to share this. Give me a second. I'm gonna switch to a different tab really quickly. So for those of you who are interested, I know some people have reached out about this, but for those of you who are in the process of applying for internships, or you need some kind of like internship help, especially when it comes to technical interviews / leak code, those suck. if you're very new to software engineering, I have a really awesome resource that you can use to brush up on your LeetCode practice. So let me, damn it. There we go. Let me go to my, whoops. This is going to take me a quick second, but yeah, for those of you who are in the middle of your application process or need some LeetCode review and you don't know where to start or how to learn or anything like that, here's an awesome resource that you can use. It's made by LeetCode or NeetCode. You might have heard of them. They're an awesome company, but basically I'll post this in the ed too. But this will get you like the fundamentals down for LeetCode interviews. So let me share my screen. Sorry, this is just a little filler, but yeah, there's something called the NeetCode 150. I am still working through these. As you can see, I'm also in the middle of the grind, but these are all the styles of questions that you would kind of need to get the fundamentals down in order to ace all the technical interviews. So for example, they have all of these questions and techniques in order to solve certain LeetCode problems. Basically, a lot of technical questions can be narrowed down to certain categories. So like we have different questions that correspond to like backtracking, heaps, 1D dynamic programming, questions that use arrays and hashing. So this is a great resource. Basically, you go on any of these, you create a LeetCode account, you click on the link, it'll take you to the LeetCode website where you can kind of solve the problem on your own. And if you get stuck, they have a solutions right here, and they have a walkthrough video right here to show you how to accomplish the problems. Basically, they say, and I don't know if it's true, but it sounds pretty good from what I've heard, go through all of these, you'll be like 50 to 75 to 80% prepared, more prepared than if you hadn't done them at all. So that's good practice. I did the first one and it was pretty fun, but I do feel a little bit more prepared. But yeah, I'll drop that into the ed soon as well. For those of you who are curious, let me share my screen back. Oh, where did my thing go? Okay, and then we'll get back into the lecture. Cool. All righty, 5-minute break. We are now moving on. So the big stuff, we have AI and machine learning concepts that are used in AWS services. And AWS has offered a multitude of different AI and ML services that help users and consumers alike in creating applications that use these features. So you don't necessarily need any AI or machine learning knowledge prior to using these services. They do a really good job of walking you through how a lot of them work. And all you need to do is really implement them. So they abstract away so much of the knowledge you need to actually go through with some of these services. So to put that into perspective, we have, let's give a brief background about AI. So like AI is just essentially a system in which you like teach computers how to behave like humans and make choices that seem rational from a human's perspective. Although they're not always the optimal choice, perfect AI is the system in which you're always making the optimal choice. But yeah, AI is trying to replicate human interaction and human decision making to do all the dirty work for us so we don't have to do much of the thinking. And machine learning is like a subset in a particular form of AI. It's basically creating like intelligent systems that learn and teach themselves how to do things without us having to teach them. So they learn on their own. They're like babies trying to get through life. And they use like a lot of models and mathematical algorithms to kind of take in data, learn from the data, and use it to create new decisions. So that's what machine learning is, and that's what AI is. Good stuff to know. Awesome classes at Berkeley for that. So the first AI/machine learning service is AWS Rekognition, spelled with a K. It's image and video analysis in the cloud. It's pretty cool. This is a really awesome service that we'll demo later. You basically are able to feed in text, or not text, you feed in pictures or videos, and Rekognition can do a lot of cool things like detect text in the videos, detect faces, classify objects in your video, and like more analysis tools above that. It can detect your emotions if you like submit a picture of yourself. Just some examples. And they use like their own machine learning / AI architecture and algorithms to do that. So you don't have to implement any of it. All you have to do is use their service. And you can use Rekognition, for example, to like block inappropriate content from being posted on like a social media app. If you made like an Instagram clone and you don't want people posting their, how do I say this? Their hot dogs onto the platform, you can use Rekognition to automatically detect, oh, this is a hot dog. We don't like hot dogs. So yeah, Rekognition, very useful and very simple, and also very cheap compared to building your own AI model to do that. Okay, next we have AWS Comprehend. So Comprehend is a natural language processing service that gets information from text that you input, and it can do a lot of cool things with the text. It can analyze the text for insights and sentiment and see relationships between text. And then basically it's like you feed in something to Comprehend, and AWS Comprehend comprehends it. Like it takes that and then gives you an output of what it thinks about the text. And it's very accurate, to a very high degree of accuracy. So you can, for example, you can use Comprehend to run analysis on like customer reviews. Let's say you created a product and you have a bunch of customer reviews. You can use Comprehend to go through every single review set, and it'll give you a summary of how people think about your product. They'll be like, oh, this product is like dog crap. Or it could be like, this product is pretty amazing. And you don't have to do any of that. Comprehend will do all the work for you in batches. So you don't have to go through every single comment. Comprehend will do that. So pretty cool. And the natural language processing service, that's what you need to take away from this one. Next, we have AWS Polly. Polly, like the parrot. Like literally, that's why they named it Polly. It basically turns text into natural sounding voices, kind of like feeding something in, and then you just get a voice translation of it. So it can be used for a lot of cool things, and you see it a lot everywhere, but this is AWS's service that offers it. It uses deep learning algorithms to kind of create natural sounding speeches. It does a lot of synthesis on real life voices, and it creates really natural sounding voices when you use it. It has different tones and dialects and languages. And basically you only pay for every character that's converted into speech. So you can create a whole audiobook clone using AWS Polly by taking in text and then feeding it through Polly and having Polly output the voice to read the text. So you can put audiobook out of business with this. And then next we have AWS Translate. It's like a less cool version of Google Translate. Maybe it's better. I don't use it, but it's not as well known. But AWS Translate is basically Google Translate. You can do language translation. You can translate a lot of text at the same time. So I guess one plus side of AWS Translate is you can do huge amounts of language or text, so batch language. And it supports a lot of many different languages and formats. One use case in which this might be beneficial is, let's say you have like a website that might be accessed all across the world. You can have features in your website that detect, hey, this person is accessing my English website from China. When you access it, let's translate it into Chinese and present that website in Chinese to the person in China. So this is like really cool and stuff. Like you aren't race bias or region bias in your application. So you can convert your website text to a whole nother different language depending on where it was accessed. So you can translate this to Japanese if you accessed a English facing website from Japan, for example. So pretty powerful things going on with this. And then we have AWS Lex. It's a way to develop Alexa basically, but without having to create Alexa itself. You can build a smart chatbot or like a bot that does things for you. You can like integrate it with different functions, but it'll recognize your speech, understand your language, and perform the associative function with what you're trying to do. So you can create a bot that schedules meetings for you, for example. Just like Alexa, you can just say, hey, schedule a meeting for me on Thursday, 6:30, because that's when I teach the decal. AWS Lex's bot can do that, and then you can integrate it with other services. So this is very cool stuff. You don't need to necessarily spend a lot of time doing these things when you're trying to create some awesome features in software. And this is the fun part. We're going to do a little demo. So let's see if this works. Okay, that was a weird bell, but okay. We didn't talk about AWS Transcribe, but it's just like speech to text feature. It doesn't work in this demo, but let's do AWS Poly first. So let's say I want a neural voice and I want it to be some dude from Spain. I'll be like, feel free to drop comments into chat, and then I can use them in my demo as well if you're interested. But welcome to my decal. So this is basically what I would sound like if I was from Spain.
Welcome to my decal.
Sorry, from Latin America. Welcome to my decal. Let's add some exclamation marks.
Welcome to my decal.
I don't know if you can hear that from Zoom, but basically it's saying, welcome to my decal. Let me give another example. I am so tired of the world. Very depressing. Let's see if Joey can say that nicely.
I am so tired of the world.
Yeah, that sounds about right. He's so monotone, it reflects how tired he is of the world. So that's AWS Poly. You can use this link in the lecture slides to kind of demo it out yourself. Turns text into speech. Next, we have let's do the least interesting to most interesting. Amazon Translate. Let's type in something like, hi, my name is Bowen from Berkeley, California. Let's output Somali. So yeah, that's just typical translate, kind of like Google Translate. Next, let's do AWS Comprehend. So I actually want to get some sample comments. So if people are watching from Zoom, feel free to drop some comments in the chat and I'll actually use them. In the meantime, I'll give some samples. But say something that has emotion. So like, I hate this decal. Damn, AWS can comprehend that you really don't like this decal. It'll give you a sentiment score that is in the thousands place of confidence. And then there's other features that it can incorporate. But let's say, I love you. I think you are so sexy. Ooh, it knows that it's very, very, very positive. But like, it's kind of weird for slang. So be like, you my homie for real. Yeah, it doesn't know what you're talking about. So it'll give you a neutral score. For real. Okay. Can it detect sarcasm? That's a good question. I don't think it can. And that's one of the reasons why there's always work to be done in this type of field. But let's see if they can detect what you just meant by that. It's question. See, it's a neutral comment. So let's let's copy and paste what Christopher said. Twitter got bought and the CEO was fired. Let's see if it can detect that that's like a good or a bad thing. See, it seems like it's pretty neutral, but a little bit more on the negative side because we use the word fired. So yeah, one more example. You are fat. Look, I use this example when I was testing it out. Look at this. It's AWS comprehend is fat phobic. Look at this. Fat has a negative score of like 90.96, right? And then look, now you type in you are skinny. It's not as negative. So it's just basically saying fat is being fat is more negative than being skinny. That's crazy. We need to talk to AWS about that. That is unacceptable. They're fat phobic. But yeah, in all seriousness, that's a cool way to analyze text to like a certain degree of confidence. Alrighty, and then last but not least, AWS recognition. This is cool. So I'm gonna take a picture of myself. And it'll label me, and it'll add a lot of labels to me, and it can misgender people too. This is another ethical topic within the machine learning and AWS world machine learning and artificial intelligence world. We're getting kind of weird with gender identification, but that's a whole nother topic on its own. But let's say I didn't identify as he, him, this would be controversial. It gave me 84% confidence rating. But yeah, let's say I'm gonna put up my cell phone. It'll detect that this is a mobile phone, I think. Yeah, mobile phone with 99 points of confidence. Let's see. I found this Hydro Flask in the classroom. Let's see if this hopefully detects books. Beer, okay, that's interesting. All right, last but not least, let's do a remote. Let's see. Electronics. Okay, that's very broad, but yeah, you can kind of see how it works. You can integrate this within your applications to do cool things, or you can use it for your own analytic purposes. Let's say you're uploading a lot of videos. It'll do some stuff. Whiteboard, blackboard. Nice. It got the whole color of the board wrong. That's crazy. That's crazy. All right, yeah, that's the demo for today. Like I said, it's in the slides so you can kind of figure it out and play with it yourself. But those are some cool services in the machine learning AWS sector. Now we're just gonna run through some miscellaneous services and then we'll be done. So thank you guys for hanging along and sticking with me. It's a very long lecture, but we're almost there. I won't get into too in-depth about certain things, but we have AWS blockchain services. You can create your own blockchain with AWS managed blockchain. So you can create Ethereum or like an Ethereum clone with AWS. It's pretty cool. You have your own network. You don't have to worry about any of the hardware. You can invite people to the blockchain to participate in it. And you can set up cool things with that. This is not my area of expertise, but it looks like this is a Web3 kind of thing that AWS is getting into. And then you have AWS Quantum Ledger Database, not necessarily blockchain, solely blockchain in like decentralized world, but it's just a way for you to store ledger style data. So let's say you have a system where you want to store every single employee and then how much money they've been paid out throughout their entire time at the company. That's like a ledger style data structure because you're not changing anything about the employee's pay history when you're giving them a new paycheck. You're just adding on / appending to their giant list of how much they've been paid. That's like a use case in which you'd use Quantum Ledger Database. It stores transaction logs. So you get paid $1 today, $1 tomorrow, $1 in 3 days. It'll store all of that and it's immutable. So you know that no one can go and mess with your payroll and then give you more money than you're supposed to. And it's very good for auditing. So yeah, that's AWS blockchain services. Just those two for now. You have a lot of Cloud finance tools. So remember when we said we can use storage gateway to send data to the cloud to do some kind of analysis? Cloud finance is like an example of services that you can use to do analysis. So you have AWS budgets, cost or usage report, cost explorer, savings plan, billing conductor, and more. You can integrate this with certain functions. Let's say you can do some cool things with AWS Lambda. Every time you detect a bill in your email account, you can use like some of these services and set up an AWS Lambda trigger to say, okay, I just received a bill for like $1,000. How will this affect my savings account? How much should I save for the next month? Things like that. So you can use cloud finance. Next, we have some cool front-end tools. So when you're trying to create full stack applications or web applications, you can use these tools to help you out and abstract some of the process. AWS Amplify is like a way to create a full stack application in React only, but it abstracts a lot of the back end functionality for you. So you can basically create a website without having to write too much code in a sense, like all the back end code. So that was what AWS Amplify does. It's a way to speedily create like a simple website. You have AWS Device Farm. This is really important for when you're trying to create applications that are mobile or device responsive. So when your web application is accessed on the phone or on certain computers with different screen sizes, you want to see how your UI, UX features respond to different screen sizes. Device Farm is where you can test it out in those environments. So you can have like emulators of certain devices, and you can see how different things react when you have like a phone or an iPad, for example. And then AWS Amazon Location Service. This is just a way to add geocodes or like geolocation or GPS services into your application. Not GPS services, but like, let's say you're trying to create like a geocaching app, or you're trying to create some app that requires your current location. You can use Amazon Location Service to get the pinpoint location of where you're located when you're making a request. And it helps with things like inputting your address when you're filling out like required fields, stuff like that. So cool services for the front end / full stack. Next, we have game tech. This is, again, is not my area of expertise, but from what I understand after doing some research, these help you accelerate game development processes. AWS GameLift is a way for you to deploy cloud servers for games. So kind of like going back to that gaming example I was talking about, when you're sending information to game servers in multiplayer settings, those servers can be stored in AWS GameLift. So like you can create a bunch of multiplayer servers with GameLift and then have users connect to individual ones based on location, based on skill, etc. AWS GameKit is like a way to deploy game backends from the Unity or Unreal engines when you're developing games. There are environments in which you can develop in or deploy your code. GameSparks is like a game backend service that I don't know too much about, but it's also a way for you to develop code when you're trying to create games. You have the AWS Open3D engine. It's an open source game engine that AWS is a partner on, and they're trying to create for game developers. And then you have AWS Lumberyard, which is a game engine that you can use to create cool graphics and functionality. And it looks pretty beautiful. I don't have a photo of it on the slides, but it's pretty well done. And I think a lot of popular games use Lumberyard. I don't know any off the top of my head. But yeah, this is game tech in AWS. We have the Internet of Things, or IoT. AWS is also really good in that sector. There's a couple services, but some to point out. Greengrass, it's a way to build and manage device software. A lot of agriculture companies have used Greengrass to kind of do a lot of automation in their software, like when they have like big systems in which like robots or like devices harvest or do some kind of thing with agriculture, you can use Greengrass to kind of build software for that, have all those devices interact with each other, etc. When you have security cameras and you take in live footage from the security camera and you want to process it, Greengrass can do that, and you can have integrations with that. And then AWS Button is literally like a remote control that they send you and ship out to you. It's a physical button that literally has one button, and you can do cool things with it, like turn on like smart lights or your TV or your garage door. So it's like a physical AWS service, but you can like program it and do integrations with it. You can have a button that sets an alarm. You can have a button that turns off an alarm with your phone. You can have a button that sends out an email or automated response. A button that you can, oh, this is a good example. You can have a button that takes a photo from your camera. So it's like a selfie stick, but you can just place the photo far away from you and click the button and it'll snapshot it. That's a good use for AWS Button. But yeah, Internet of Things, these are some examples. Next is AWS Media. You have a family of services in AWS Elemental. So you have like Media Connect, Media Convert examples. They just use Elemental as a service for like streaming and on-demand videos. I don't know too much about it, but it's kind of like a way for you to send data when you're dealing with media and files. We have Nimble Studio, which is creating visual effects in the cloud. And there's a lot more, but you can create, I guess, visual effects in the cloud. And never heard of it, but it's also a very broad thing that AWS offers. And then some cool and niche areas. You have VR and augmented reality. You can do that in AWS Sumerian. So let's say you have a web application where you created like a website for an apartment complex that you own. You can use VR and AR integrations with Sumerian to give the user who accesses your website an idea of what the rooms or apartment looks like in VR. So that's a cool way to think about it. Sumerian is a way to do that. You have AWS robotics services in RoboMaker. So RoboMaker is like a simulated environment in which you can run your robotics software. So let's say I just came up with iRobot. I can test out the iRobot algorithms and software in a virtual environment with RoboMaker. So when you're testing it out, you'll see like a virtual version of iRobot doing real life situations and simulations. So you could do that in the cloud versus doing it in real life, and it saves you a lot of time and a lot of money. So that's a good use case for RoboMaker. You have AWS Ground Station. This is a way for you to create a whole ground station that interacts with satellites that you deploy. So this is like a whole nother level of like business that you're dealing with here. People who use AWS Ground Station have like literally their own satellites in space, but basically AWS Ground Station communicates with the satellites that you own. So let's say AT&T wanted to use Ground Station. Now they can use, they have a ground station in the cloud that can interact with their satellites in space. Yeah, pretty impressive stuff. And then they have AWS Bracket, which is a way to run algorithms or anything you want on quantum computers. And this is also a very new thing, but you can have quantum computers in the cloud. So that's awesome. You can mess with qubits, run algorithms, try to see if you can solve P versus NP, P equals NP. You can do that in AWS. So, all right, it looks like we've reached the end of our lecture. So thank you all for showing up. I really appreciate those of you who come in and take the time to do this. Remember, there's a lab due next Thursday. So the word of the day is lab. But other than that, if you have any questions, leave them down below. But have a good rest of your day, and I'll see you all next week. Thank you, guys. And good luck with midterms if you're still having those, and homework and things like that. We'll keep in touch.